So I've replaced these 4 Battleborn batteries and taken off this battery equalizer and installed the new EG4 5 kilowatt hour 48 volt waterproof battery cells. So there's been a number of changes that I've done in the system. First and foremost is I've added some Victron components. I'm a big fan of Victron. So I have the Victron Serbo GX down there, which is sort of the brain of the system, and it is monitoring the battery via a Victron BMV712 shunt. So I can get the actual battery capacity and how much current or amp hours that's been drawn from the battery, and in addition a monitor which currently is displaying the battery voltage, and then this gigantic telephone cable is connecting the two. I need to clean that up a bit, and then this Serbo GX is also connected to a Victron charge controller, so I can now monitor my actual PV power online to, basically gauge how much power I'm getting and how much power I will be getting, to make sure that I'm not going to discharge this battery too much and set the the appropriate charge current for the car as the day progresses. So this battery, which is the new addition, is 85 pounds. It's going to be about 25 pounds lighter than the 4 Battleborn batteries. It's clearly almost a perfect fit for this frunk. It's really small. If you recall, I originally bought a EG4 LiFePO4 battery for the car, which is a server rack battery, and it didn't really fit in the frunk or in the trunk well. Version 2, I sort of moved the batteries to the frunk and replaced them with the Battleborns, and now this seems to be a much better approach. This battery is about $1,500, something around that price tag, depending on whether or not they have a sale. So it's still a really good deal, given that the 4 Battleborn batteries over there are around $800 a piece. So this is significantly cheaper. One thing that I've been experiencing now that it's winter and it's cold is that the capacity has been sort of decreasing, and essentially the voltage is much lower on the batteries when it's cold, and you kind of trigger the low voltage alarm earlier. So it'll be interesting to see how this new one does. The Battleborns seem to be better than the EG4s. So my EG4s in the garage seem to suffer from decreased capacity compared to the Battleborns. You can of course set things lower, but ultimately to keep battery life up, you keep those basically the same throughout the year, so as to not decrease your lifetime of your battery. So overall, it's still an ugly install, but it's a cleaner install. I've got 2 additional wires that are connected to the positive terminal, one of which powers the Serbo GX. Okay, that's the brain, and the second goes to the shunt. So the shunt is directly monitoring the battery terminal voltage, and then the servo just needs to draw power. and then on the negative I have nothing. Okay, and that negative goes up into the shunt on one side, and then on the other side of the shunt I have the negative of the Servo GX. And the battery monitor doesn't need negative because it is the negative basically. So one thing I noticed that is if I didn't charge for a few days when I had the Battleborns, the slight current draw from the Servo GX over 24, 48, 72 hours was enough to actually draw the battery down without the battery monitor knowing. And you repeat that process sort of over, and just even if you charge during the day, you repeat that process over many nights of not charging, and you're not going to account for the very, very small draw. But eventually, with a small battery system like this, it adds up. And over, say, 2, 3, 4 weeks, the system would have basically shown that it had a significant charge, but the whole system was actually lower in capacity and would cut off earlier than I expected while I'm charging at work. So overall, I never actually thought to connect the Servo GX to the negative terminal of the shunt, basically the non-battery terminal of the shunt. But it does draw some current, and what I've noticed is it's around 5 to 10 watts every few seconds. So it like turns on and turns off and turns on and turns off, and I've actually confirmed that with my amp meter. So it's not a continuous draw, but it's more of an intermittent draw. But it seems to be significant enough that over long periods of time you can get significant decreases in capacity. And the only case when this is the issue is that if you don't fully charge your system. So in my case, I would basically drive to work, start charging the car, and never actually charge the battery to full capacity. I wouldn't reach absorption voltage levels, which in this case is around 56 volts. So I had some issues with that. And so last but not least, I think you can see there's a little USB cable here that's powering this little T-Mobile Wi-Fi hotspot. Okay, so this thing is connected to the Servo GX and transmits all of the battery voltage data and also the solar charge data, or the charge controller data. So I think what I was really missing with the EG4 inverter was the ability to monitor the PV power basically away from the car without having to connect to Bluetooth. And as I've stated earlier, the Bluetooth system for the EG4 inverter is really bad, and it has an online system that can connect to Wi-Fi, and it's just basically terrible. Actually, I think the whole thing is Wi-Fi, excuse me. It's not Bluetooth. And it's pretty much useless because it's just full of bugs. This battery has a Bluetooth system, and it appears to work pretty well when you're in close proximity. You have to basically pull it up, which I can do right now actually. So we'll do that. Okay, so pull up the EG4 system, and then it shows about 1 million devices that are in close proximity, and mine starts with a Z, and it happens to be down there, and this is the current state of charge of the battery. It arrived at 55%. It's currently at 100%. And it gives you the cell temperature, which is 18°C right now, because I had it inside. And it gives you all of the cell voltages. So this thing is incredibly matched right now. Everything is less than 10 millivolts between each cell, and it seems to work well. The inverter app is not as good, but Bluetooth is only close proximity, so I want the ability to monitor this thing essentially while I'm at work, and can just check in and see if everything is going okay. And that's the main reason I went with the Victron components. Okay, so moving to the back of the system, I've got the panels down, hatch is open. The system is basically the same, except there's no batteries in the trunk. The main addition again was to add this Victron charge controller, and so it resides currently behind the unit, just mounted, and PV wires come in through down here, like they used to. And the only addition that I had to do was to add this blue Ethernet cable. So unfortunately, because the battery monitor and the shunt need to live near the battery to appropriately monitor the battery voltage and not essentially account for any voltage drop across along the lines, I had to rewire this Ethernet cable. And while I was doing that, I also doubled up the wiring for the battery. So the battery now has two wires for positive and negative as opposed to just one, and so that now there's basically less resistance. And I chose to run two wires instead of a single wire, basically because they can lie flat. So as you're running along the floorboards of the car and whatnot, you can sort of more easily lay out four wires as opposed to just two. So ultimately I think this thing could be miniaturized greatly, and sunk into the actual cavity there in the trunk. But I don't really need the trunk much, and I've got some space over there. And then last but not least, everyone should appreciate that I now have a pop-up cone that I lay out when I roll out the solar arrays. So that's the update. See that these three have a different sticker than this one. So this is one of the very first Battleborns I bought, now less than, say, a year and a half. And this one has reduced capacity, so it got cycled really hard, and I probably made some beginner mistakes early on. I only had 2 Battleborn batteries total for a home system that I was using to charge the car. And essentially, you can tell that this one drops voltage, at significantly lower capacity than the others. So I think somewhere around 50%. When these are, when the battery monitor says that these are at 50%, this one's like almost dead. And so I bought a battery equalizer, which is a ASABA. It's a Chinese brand that basically it starts passing current between all of the cells when there's a 10 millivolt difference. And it works, thankfully, and it's worked for about a month. And what the only issue with it is that it can't keep up with the incoming PV. So if you have 1,000 watts in, and say this battery is kind of on its, much lower than the others, or even much higher necessarily, that can happen too. It can't equalize more than 10 amps. And so, if you have 20 amps coming in, or even 10 amps coming in, it's not going to do the equalization that you need. So you really need to let it kind of settle, or be an absorption where you're kind of, just charging slowly for it to equalize. And it does say it takes 24 hours to equalize a system. I believe that. But overall, it's a bit of an annoyance, and I think I'm actually going to send this one back to Battleborn. It had a, like I said, it had a sibling that was really showing degradation, and I sent it back, and they actually sent me a brand new battery, one of which is here. I'm not sure which one. But I think there was just an issue with this. I bought all these batteries from Battleborn, and this one I bought from Inverters R Us, sort of, pretty, within a few months of each other. And clearly it's, got a different sticker, and something else is different. But so okay, so why am I doing all that? Why am I adding Victron components and all that? If we go back, if you remember, my home system is running off of a LabVIEW program that connects to my Schneider equipment. So I basically don't like the interface for the Schneider equipment, and so I made my own by writing LabVIEW and Python code to communicate with the system and pull all the specs that I want in one little place. And so this is a little micro PC that runs this in the garage, and it uses Modbus and whatnot to communicate with the system. It also runs current voltage curves on the two max power point trackers, because so if you recall, when I added the rapid shutdown devices to the system, it stopped tracking power, the maximum power. And it works for my smaller charge controller, but the higher voltage charge controller still doesn't work. And so this periodically runs IV curves and finds the maximum power point. It's really cloudy right now, so this is kind of a mess. This should look like a normal IV curve. And then that data is now dumped into a website, or an SQL database that connects to a website. And it's called gridfreeordie.com. And this is kind of an image of the website. And so now, in addition, I've added code, Python code, to communicate with the Victron API. So you can basically pull data from the Victron API, whatever you want. This was not trivial. The instructions are pretty poor, and the API is not officially supported, but it works. And now you can basically get your Victron data and the Schneider data all in one plot. So if you kind of look at, let's see, the car is not charging right now. So in its simplest form, we've got two maximum power point, or two charge controllers, Arca, and then that's the total power coming from the two systems on my house. Then you can add the mobile, which of course is not on right now, and essentially plot everything here. This is the battery voltage and capacity throughout the day. this is a little plot that shows where the sun is based off compared to the normal of my array, which is sitting at 10 degrees. And essentially right now we're at winter solstice. We're very close to it. And so you can kind of zoom in, and the black line is the current day's path. And the blue line is winter solstice. And so it's gradually going to come up to the red line in the summer. This is a plot over here of the cosine loss as a function of time and year. And so right now, the calculated altitude and azimuth is 24 degrees and minus 34 degrees from due south. And so the incident angle is 58 degrees onto my 10 degree inclined array, which results in 46% cosine loss. And so essentially I'm losing 46% because I'm not tracking the sun. And then the last two plots are the voltage and current of each charge controller and IV curves if I'm actually using my software to find the max power point. And these, look kind of prettier. You can maybe change the date and get a better image. So here's yesterday. There's your current voltage and power voltage curves from the higher voltage charge controller. And you can see that, I accumulated 2.4 kilowatt hours from the array over my garage, which is mostly shaded. The array on the second story roof was 12, and then my car generated 4.2 kilowatt hours for a total of 18. So that's been my fun project, is to sort of connect Victron and Schneider together, and I can go to one website. Okay, I don't have to log in. I don't have passwords. It's just there, and I can see it on my phone. I can see it inside the Tesla, or I can see it, at home or at work or anywhere. And if you're interested, you can click on the math link, and it tells you how to calculate these various plots if you so choose.